Jai Hind everyone, I am Vaishali Rastogi. Here I am having the topic of scheduling algorithm from the subject of operating system. In this video, we are going to learn about few scheduling algorithms which are first come first serve FCFS scheduling, shortest job first SJF scheduling, priority scheduling, preemptive priority scheduling and non-preemptive priority scheduling. We are having few more scheduling algorithm which we will cover in our next video. So let's start with the first algorithm, which is first come first serve FCFS scheduling. First, before going with the algorithms, we should know why we are doing this and what are the scheduling algorithm is. So a process scheduler schedules different processes to be assigned to the CPU based on particular scheduling algorithm. Like if we have so many processes in our operating system and every process wants to execute themselves in the CPU, they want CPU time. And every job is fighting with each other so that they can have the CPU first. But we have to make a process that this is basically the algorithm all the process have to follow. And these are the basic algorithm which we call scheduling algorithm. Here we schedule in a manner that this is the way that every process have to wait, or every process will get their time in some manner. So these are the various types over here. Let's start with the first one, that first come first serve. So here I am just directly going with the example first. What is the meaning of first come first serve? Like if I am standing in a room and I am just checking the copies of all the student, then how I will check? I will start with the first come, or whoever the student will come first with the assignment or copy, I will check their copies first, and so on, and next and next and next. This is the basic concept of first come first serve. Let's write with some few example. Like if there is a queue, let's go with the example first. Let's suppose there is a queue on a railway station and there is a counter of ticket. Whomever the person is coming first from here, and this is the ticket window, this person will come first and will get the ticket from here, and after completion the task, it will remove from here. Another person will come after the first person. He will take or she will take the counter after the execution of first is over. Before, if the first person is at the counter here, second person have to wait for their turn. So this is the meaning of first come first serve FCFS scheduling, that whomever is coming first, they will get the CPU first, and after the process will get the CPU in a sequence manner of the depending on the arrival time, or if we are having arrival time over here 0, 1, 2, 3, then we will go further. Otherwise, right now in this example, I'm just having simply a process name is P1, P2, P3, and I'm having the burst time of each process. Let's do with the example of this question. So right now I'm just imagining that P1, P2, P3 are in a sequence. Means P1 is coming first, then P2 and P3. So how I will solve this example? In this kind of scheduling algorithm, we always make a Gantt chart. After creating the Gantt chart, we will try to find out the waiting time, and then after having the waiting time, we will create the average waiting time for that particular processes. So let's create the first. This is our basic Gantt chart, which is going to start from the time 0. Right now, a CPU is having at time clock 0, and first process is coming to the CPU, which is P1. P1 require 24 burst time. 24, we can consider it seconds, nanosecond, microsecond, whatever you want, you can consider it as like that. So first we are having P1 and it's having the time of 24 seconds, nanosecond, you can assume as per your choice. So P1 will enter first and get execute for 24 of time. After P1, we are having P2 process, which require the CPU. After completion of P1 up to 24 time, P2 will ask for the CPU time. So P2 will enter into the Gantt chart and it will ask for the time for 3 seconds. So 24 is already have been done in CPU time and 3 seconds also P2 required. So how much total we are having? It's 27. Then we are having process P3. P3 is also requiring the time of 3 seconds and currently CPU clock is saying that 27 seconds already have been passed with other processes and 3 seconds required by P3 process. So after 3 seconds, the CPU clock will move towards a 30. So now we will find out the complete waiting time for each process. So we can write waiting time in short like WT. So how we will find the waiting time? Waiting time is nothing but the time which a process wait for getting the CPU. So how much time P1 wait for the execution? It's basically 0. At time of 0, P1 got the CPU. So for waiting time for P1 will be 0. Waiting time for P2 will be 24 because after 24 seconds, P2 got the CPU. So waiting time for P2 is 24 and waiting time for P3 would be 27 because after 27 seconds, P3 got the CPU. So these are the waiting time for the separate basis. Now we will find the average waiting time. It's nothing but the 0 plus 24 plus 27 divide by 3. So how much we will get? We will get simply 70. So the average waiting time is 17. So this is the way of simplest algorithm, which is first come first serve. Let's move toward the next algorithm, which is shortest job first. What is the meaning of SJF scheduling? This scheduling is basically works for the shortest time duration. Whomever the process having the shortest time to execute their task, that process will have the CPU first. Okay, simplest. It is completely simple. Like right now, like if I am the CPU and I am having 2 to 3 choices. So what I will see that which process is requiring the lesser time. Whomever is requiring the lesser time, it will get the time first, CPU first, else they have to wait. They will come in the sequence of their required burst time. So we will design this algorithm on the basis of their shortest burst time. Okay. So again, I'm creating like, let's take an example first. Like here is a machine which is just printing some pamphlets and 3 people are there. This person, A person is saying that it have to print for 10 papers. And the second person is saying it required only 3 papers to print. And third person is saying that it required 7 papers to print. And this is the printing machine basically. So we will print the paper of this one's first because it is having only lesser 3 pages to print and it will take lesser time. So we will go with the first 3. Then we are having 10 and 7. This person is requiring for 10 prints and it is requiring for 7 prints. So we will go for the 7. Then after completion all of these both, we will go for the third person's choice. So as we will do over here. So you can see there is example P1, P2, P3, P4 and these processes are having the time of 6, 8, 7 and 3. So just imagine, give some time to yourself and tell me which process will get the CPU first. So let's start with the Gantt chart. Again, CPU clock is at 0. Here we are having 6, 8, 7 and 3. As I have already told you with this example, that we are looking for the 3 second smallest. So P4 will get the CPU first for 3 seconds. Then this has been done. After that, we are having 6, 8 and 7. Then we can see that P1 is having the lesser time among all these process. So P1 is looking for time 6. So 3 already has been done and 6 P1 is required. So we will just go for the 6. 6 and 3 is 9. Then we are having P2 and P3. Here we will see that which processes have requiring for less time. So P3 is requiring for less time. P3 will get the CPU. So now we can say that it will be 16. And then P2. P2 is requiring for 8 seconds. So what will be the complete time of this complete Gantt chart? This will become 24. Now again we will find the waiting time for each of the process. Let's find it. WT for P1 is basically 3. For P2 is 16. For P3 it's 9. And for P4 it is 0. So now we will find the average waiting time. Now we will calculate the average waiting time over here. So 3 plus 16 plus 9 plus 0 divided by 4. So the average waiting time we will have as 7. Okay, so this is all about shortest job first scheduling algorithm. Next algorithm we are having as priority scheduling. What do you mean by the priority? Priority is basically a number which decide that which process will execute first. This is a symbol, or we can say that a kind of token that this, like if we can assume the priority in real life, that what is the priority of if we assume if we take example for priority, we can take the example from our home, that we are having a grandfather, father and kids. So which one is having the higher priority? Our grandfathers, then father and then childs. So this is the complete sequence of priority. So again, let's back to the question. So priority is nothing but that it decides that which process will come first. Whomever process is having higher priority, it will get the CPU first. As it is as simple as that. Okay. So in this example, we can see that we are having 5 processes which are having some burst time according to their need, and also having some priority number. We can see that P1 is having priority number 3, P2 is 1, P3 is 4, P4 is 5 and P5 is 2. So we can see that the 1 is having the higher priority and the 5 is the lowest priority. So we will execute or provide the CPU time according to the priority. So again we will create a Gantt chart. We're starting from the 0. P2 is having the highest priority, then we will give the CPU first to the P2 process. P2 will have for 1 second. Okay. Then again we are having higher priority of P5. Priority is 2. So P5 will have the CPU. It is requiring for 5 seconds. So 1 is already done. 5 is required by P5. So total is 6 times. Then again we are having higher priority of P1. P1 is requiring the time of 10 seconds. The total will become 16. Again, we are having the higher priority of P3. P3 is requiring for time 2 seconds. So it will get the CPU for 2 seconds. It become 18. And last we are having P4. So P4 will get the CPU for 1 second. It will become total 90. So you can see that in this algorithm, we are only looking for the higher priority jobs first. It is as simple. So let's find out the waiting time for each process. So waiting time for P1 is 6. Waiting time for P2 is 0. For P3 is 16. For P4 is 18. And for P5 is 1. So let's find out the average waiting time over here. Six plus 0 plus 16 plus 18 plus 1 and divide by 5. So what we will have in answer? It's basically nothing but the 8.2. So this is the complete priority scheduling algorithm. So let's move towards the different versions of priority scheduling. First one is preemptive priority scheduling and another one is non-preemptive priority scheduling. Now we have learned about the priority scheduling, and next we are having two versions of priority scheduling, which one is first preemptive priority scheduling, another one is non-preemptive priority scheduling. So we will continue this two versions in our next video. So here I'm just stopping the video over. Thank you.